All right, we're going to start chapter 8 today. So we've done chapter 6 and 7 this semester. Moving on to 8. We got 8, 9, 10, and 12 to go. Chapter 8, we are actually going to shorten it for you, though. You're welcome. We're going to do 8.1a and b. So we're going to do 8.1a today. We'll do 8.4, 8.5, and 8.6, A and B. And that's it. Just really 4 lessons from chapter 8. We'll do 1, 4, 5, and 6. And chapter 8 is called Rational Functions. That sounds fun. Okay, and today we're going to go a little old school on you. We're going to go back in the day when this worksheet that you were given today. If you haven't gotten the worksheet, ask for it now because you really need that. And I'm going to walk you through it. You could read it if you want to. If you don't want to listen to my voice or watch me do these problems, you can always read the packet. It shows you exactly how to do them in paragraph form, and then you just start your problem. So 8.1a, we're going to talk about 2 types of variations. We're going to talk about direct and inverse variations. And so if you look at that packet, it has you starting with direct variations, and then it'll have you do some problems, and then you'll go to the next page and they'll have you doing inverse variations, and then you'll do some of those. And then there's mixed, and the mixed is tough because you have to decide which one's which. So let's go ahead and start with direct. And how do you tell if something is a direct variation? Well, a direct variation is going to be when two quantities change in the same direction. Change in the same direction. When two quantities change in the same directions. For example, if your first quantity is going up, then your second quantity will also go up with it. And if your first quantity is going down, your second quantity is going down also. So let me give you some examples of direct variation. If you're going on a trip and you talk about the distance that you travel, whether you're going home to China or you're going out to the desert for the weekend, you're in the car, and the distance that you travel... Oh. Yeah, Sophia's. Yeah, just hit no right now, okay? Sorry, Sophia. All right, the distance that you travel and the time that you spend going there. Time spent. So if you're in the car for a long time, then you've traveled a long time. Or if you've traveled to China, you know that that's a lot of time spent traveling there. Okay, another example would be the pounds of apples that you go to the store and purchase. The pounds of apples and the money that you spend. So the more pounds of apples that you buy, the more money that it's going to cost you. It's a direct variation. If you're a baker and you like to bake, how about the amount of sugar that you use in a recipe? If you're going to up the sugar, well, then you better up the other ingredients like the butter that you use if you're baking something. So if you wanted to double your batch, you would put more sugar in, but you'd have to put more butter in too. One more. Let's just do one more. How about the time that you spent studying for that test last night, the time you spent studying, and the grade that you get on the test. And you know, this is kind of cute and fun. It might not be true, but the more time you spend doing these problems, working them out, trying to figure them out, memorizing your formulas, maybe the better grade that you're going to get on this test. We'll see. I'll grade them when I get back. All right, now, in order to solve a direct variation problem, direct variation has an equation that looks like this. It's linear, and it's just y equals kx, where k is a constant, and y and x are variables. And in order to solve to solve these problems, what you do is you actually solve for that constant. All of the constants are going to be y over x. And so if all the constants are y over x, then that means that all of their proportions are equal. So you're going to set up proportions to solve. Proportions to solve. And please do the setup on that paper. I'm not going to accept just answers circled. That packet that you have right there, you need to show me the setup on the side of it in order to get full credit on that packet. So let's go ahead and start our first example. Okay, now some of these problems are old school, so they're kind of fun. There's one even about cigarettes later on, which is really inappropriate for a high school math book, but it came out of a high school math book from like the 70s or something. It was my dad's worksheet. All right, number one. So if 4 bottles of milk, who buys bottles of milk anymore? I don't know, but if 4 bottles of milk cost $2, then how many bottles can I buy for $8? How many can I buy for $8? Okay, there's a couple different ways to solve these problems. I like to set up a proportion. So I like to first think, is this direct variation or inverse variation? We don't know what inverse is, but I can think of it this way. I have 2 things going on. I have bottles of milk and cost. And the more milk that I buy, the more cost that it's going to be, the more money that I'm going to have to pay. So let's do the cost per milk. So you can set it up like this. $2 is to 4 bottles. I like to put the words or the cash money sign there. $2 per 4 bottles. $8 per X bottles. And did you notice that up top I put the money, and on the bottom I put the bottles, and it has to be that way. Whatever goes up top is both for both proportions, for both fractions. Whatever's on the bottom is the same units also. And then we can solve this by cross multiplying. So you have 2 over 4 equals 8 over x, and you cross multiply, and you get 2x equals 32. Divide by 2, x is 16. Now I am going to mark off if you don't have units there. Okay, so 16 what? 16 kittens? 16 bottles of milk. That's a lot of milk for all those kittens, I guess. All right, so that's the first one. Okay, let's try another one. Number 2. A 10-minute phone call, and this is archaic too. A 10-minute phone call will cost you $1.20. Wow, that's expensive for a 10-minute call. How much does a 23-minute call cost? How much does a 23-minute call cost? Okay. The more time you talk on the phone, the more money it will cost you. Probably not nowadays, but back in the day. So let's set it up. And it doesn't matter how you set this up. If you want minutes up top and money on the bottom, or money up top and minutes on the bottom, it really doesn't matter. So if I start with 10 minutes is to $1.20, as 23 minutes is to question mark money. Okay? So I set up a proportion to solve, and then I simply cross multiply. So 10 times x is 10x. 23 times $1.20, you might want to get your calculator out, is 27.6. And then divide by 10. So it will cost you $2.76 to make that phone call. Are they worth it? I don't know. Okay. Second part. Inverse variation. Inverse variation. That means when two quantities change or vary, I'll say change Two quantities change in opposite directions. Opposite directions. Okay? So for this, if the first quantity is going up, then the second quantity is going down. Yeah, both of my kids are sick. They sound really bad. Or if the first quantity is going down, the second one would be going up. So they change in opposite directions. For example, the number of people on a job site and the time it takes to do the job. Right? And this might not always be true, but the more people that you have, maybe it's a big cleanup project at your church, the more people that show up that day to do that job, well, then the less time it's going to take because everyone's working together. So that's great. Another example would be, how about the speed of your car in the morning when you're driving to school and the time it takes to get to school. Time to get to school, unless you're speeding and you get a ticket and it takes you longer. But if you're going faster down the street or on the freeway, then it's going to be less time to get there. If you've ever sat in traffic, you understand that very well. Now, in order to solve these are equal, y equals k, and they vary in opposite directions, so it's going to be divided by x. And that k, that constant there, is equal to x times y. So what happens is all of the constants, k, are equal to the products of your quantities. And so what you want to do is you want to set up x1, y1 equals x2, y2. You want to set up products equal to each other, not proportions. Okay, and that's the hardest part, is knowing which one to do. So you have to decide, is it direct or inverse variation? So here we go, number 3. It says you've hired 3 people. I'm sure this packet will say 3 men because it's, very sexist. All right, three men or 3 people to paint a house. And they can get it done in 2 days. One of the guys calls in sick. So how long will it take? Will it take if one guy calls in sick? Like me, I called in sick today. Both children's are sick. Playing a zone defense over here, people. It's not fun. All right, 3 people paint a house. So we got to set up products, because the more people that are going to paint this house, the less days that it will take. So it's 3 people times 2 days equals, now one guy's sick, so how many people are there? 2 people times, we don't know how many days. So if you look, this is people, and that's days, and that's days. So you get 6 equals 2 times d, divide by 2. It will take 3 days now to paint the house instead of 2. All right, what else? Number 4. Let's see, I gotta make one up. Let's say that there are 50 kids going to camp. And you have enough milk to last these 50 kids 10 days. Okay. Except, 10 kids, let's go 15. 15 kids don't drink milk. Do you drink milk? I don't. Milk's gross. 15 kids, no milk. So how many days will it last? Okay. The more kids that you have at this camp that drink milk, the less days that the milk is going to last. So 50 kids for 10 days equals, now 15 kids don't have milk. Am I going to write a 15 there? No, I'm not. You don't want to write a 15 there. How many kids are going to drink the milk? 50 minus 15. 35 times the number of days. So 50 times 10, and then divide by 35. So the milk's going to last you about 14.3 days. Okay? Now, when you get to this section in your homework on that packet, they're all going to be the same. You're going to set up products equal to each other. So, inverse variation for those second group of problems, it's going to be like AB, A1, B1 equals A2, B2. Okay, set up products. For direct variation, it's A1 over B1 equals A2 over B2. Okay, that's the main key thing that you want to know in order to solve these, and then you just solve them accordingly. All right, good luck. Hopefully I'm back on Friday.